Okay, let's do a practice problem that's going to get you ready to do assignment number 17. Hopefully you've watched the video and taken some notes. And this is just one more look at doing some hypothesis testing. So we are going to do the hypothesis testing in the standard 4 steps. Let's start off by identifying the key pieces of information that we're going to need to do that. Test if the mean number of letters in the last name of Math 240 students is more than 8. A random sample of size 7 from all Math 240 students resulted in a sample mean of 8.4 and sample standard deviation of 1.7. All right, so here are the pieces of information that we have. We know we have a sample of size 7, so we can say n is equal to 7. And from that sample, we have a sample mean of 8.4, so that's telling us x bar is 8.4. That's our statistic from the sample. And then we have a standard deviation of 1.7. So S, sample standard deviation, is 1.7. Okay, now our first step is to write down the hypotheses. So we know we want the null hypothesis and we want the alternate hypothesis. We want to identify which parameter this is a test about. Well, we are given that it is a test of the mean number of letters. So as we put in the parameter mu, that's going to go in both of the hypotheses. Now for the null, we can always put in an equal sign for the next thing. And for the alternative, our options are greater than, less than, or not equal to. So we want to look back and see which one it matches up with what is in the write-up. Well, we want to test that the mean number of letters in the last name of Math 240 students is more than. All right, so that's going to go along with greater than. So we want mu greater than. And then we need a value to plug in there. Well, it's more than 8. So that is our mu sub 0. All right, so mu sub 0 is equal to 8. That's the fixed value that we are comparing the mean number of letters in the last name to, that fixed value of 8. Now, one other thing is that instead of having equals in the null, we could have mu less than or equal to 8. We always want some piece of being equal to, and whether we just use the straight equal to or the opposite of what we have in the alternate, either one of those will work. So we can have either mu equal to 8 or mu less than or equal to 8. And that gives us the first step. Second step is to come up with the test statistic. And we got to figure out if it's going to be a z-value or a t-value. So here's the criteria. We want to look at what the sample size is, and do we know sigma? Well, the sample size is it's 7. That is definitely less than 30. And sigma, well, it is unknown. We do not know population standard deviation. Because of those two things, we are going to use t. And that t test statistic is calculated as x bar, the sample mean, minus mu sub 0, all right, that fixed value in the hypotheses, divided by, because we don't know sigma, we're going to use s, divided by the square root of n. So for our example, x bar is 8.4 minus mu sub 0, which is 8, divide by the sample standard deviation 1.7, divide by the square root of n, which is 7. Okay, we plug that into the calculator and we get 0.6225, and it's repeating. Let's round to 3 decimal places, and so we get 0.623. Okay, so that's step 2, the test statistic. The third step is to find the p-value, which, as a reminder, p-value is going to be the area in the tail, in this case to the right of the test statistic. So here's our test statistic, and it's to the right because our alternate hypothesis has that greater than. We have a right-tailed test. So this shaded area right here that is the p-value. We're going to use the tool, the online tool that there's a link for on Foxtail to come up with this. So if you go to that link, this is the page, and there's a place to put in the t-score, so a t-value. So let's put that in, 0.623. And we want the degrees of freedom. The degrees of freedom is 1 less than the sample size. So our sample size is 7, so degrees of freedom is 6. The significance level, which we don't need that to calculate the p-value, but in step 4, that's what we're going to compare it to. So let's leave it as 0.05. That's what's in the write-up. And then we want to identify, is it one-tailed or two-tailed? And it is a one-tailed test, so we'll leave it like that. And finally, calculate. And our result is p-value is 0.278104. So that is our p-value right there. So we could say that is 0.2781. So the fourth step is then to come up with our conclusion. So here's where we want to compare that p-value with our significance level. So in the write-up, our significance level is given to us as 0.05 alpha. And just as a reminder, we are going to reject the null hypothesis if the p-value, hopefully you're thinking of what this is less than alpha, and we are going to not reject, or you could put in there except, so not reject the null hypothesis if the p-value is greater than alpha. Okay, well, our p-value we said was 0.2781, and that is greater than our alpha of 0.05. So that means we are going to not reject. So do not reject that the mean number of letters in last name of Math 240 students is 8.